Hi ladies and gentlemen, this project involves a survey of commercial stone fruit cold rooms measuring the relative humidity and temperature to ascertain possible impact on moisture management. Just a quick introduction. Shrivel on stone fruit is a quality concern and is becoming a more difficult challenge to manage. There is still pressure to reduce plastic and make it more recyclable. An important aspect to reduce moisture loss and shrivel in stone fruit is reducing the vapor pressure deficit (VPD) by increasing the relative humidity in the cold rooms. The objective of this study was to conduct a survey to establish the range of RH levels in stone fruit cold rooms used for pre-packed bin holding, accumulation and/or forced air cooling fruit prior to export, and ascertain the types of RH systems employed and the type of monitoring. 23 cold rooms in the three main stone fruit production areas were identified. Loggers were used to monitor temperature and RH. Questionnaires were used to get information on the type of RH system used, the room function being either a pre-packed bin room, a forced air cooling room, a room used for both forced air cooling and accumulation, or just accumulation room, and if RH was monitored and how. Evaluation of the performance was according to a scale where the trend was above 90% RH is good, between 80 and 90% RH is in the medium range, and below 80% was in the poor RH range. If we look at the results of the pre-pack bin cold storage rooms, you can see that this was done from January on to end of April in total, and the first part on the left top corner you can see that the average air temperature was roughly 2.2 degrees Celsius with the average relative humidity at 88.6%. If you look at the bottom graph, you'll see that the air temperature was there 0.5 degrees Celsius with the average relative humidity at 89.6%, with it being fluctuating up and down as the rooms are opened and new fruit is loaded in and so forth. If we look at data from forced air cooling done in dedicated forced air cooling room tunnels, we can clearly see that this was a few of the sections of the period that I took out, and we can clearly see that in three cases the relative humidity was in the poor range, being at average of 76, 72 and 79% relative humidity, and then there was three very good rooms that were above the 90% relative humidity. The one was at 90.6, the other one was at 93.6, and the other one at 93.9%, and that was in the good. And all the rest of the rooms or tunnels were in the medium range. If you look at the data from the accumulation cold room, this is a room in Paarl that we monitored. On the left top corner you can see that the average air temperature of that graph was 0.4 degrees Celsius with an average relative humidity of 87.3%, and at the bottom graph you can see an average air temperature of 0.0 degrees Celsius with an average relative humidity of 89.8%. You can also see the fluctuations in the temperature as the room is opened and closed during the day. If you look at the conclusion summary, overall the pre-pack bin cold rooms exhibited RH results on the higher side of the medium performance range set out in the work plan, with 5 rooms between 85 and 90%, 1 room in the high 80s to low 90s, and 1 room in the poor to low medium range, and that was below the 82% relative humidity. If you look at data from forced air cooling done in the 4 dedicated forced air cooling tunnels, showed 3 runs done in the poor RH range, and that's below 80%, 3 runs in the good RH range, that was above 90%, while the rest of the runs were in the medium range, that was between 80 and 90%. If you look at the 2 rooms that was used for forced air cooling, exhibited RH readings of medium to poor humidity. So that was in the low 80s to the high 70s. In the accumulation rooms, 5 of the 11 rooms exhibited RH levels in the high medium to good range. That was above the 85%, while the rest were below the 85% in the low medium to poor range. None of the cold rooms surveyed monitored RH levels or temperature, and only had readings on return air as per cooling unit and set point. In previous research, it was recommended to aim for a relative humidity of 95% to limit moisture loss from stone fruit and subsequent shrivel, with none of the commercial cold rooms reaching the desired relative humidity of 95%. I just want to thank Woodcrow for funding and continued support the cold room facilities that gave me permission to monitor the cold rooms during this survey, and all staff at Experico for their input and assistance. Thank you very much.